Good morning, friends. Today we'll be discuss Ferrites in microwave electronics. What is the concept of reciprocity? The reciprocity theorem states that when a network is terminated by a receiver at one end and the generator on the other end, if the position of the receiver and the generators are interchanged, there is no change in input signal in the amplitude as well as the phase. This network is called reciprocal network. Otherwise, it is known as non-reciprocal network. Just like it's shown in the figure. Here, the generator is connected with the network and network is connected with the receiver. The potential difference is the V1 input voltage, I1 is the input current. The output is the V2 and I2. If we interchange the position of the generator and receiver, then the generator is on the right hand side and the receiver on the left hand side. That same current will be flow from generator as well as the receiver as earlier case. Now the microwave properties of the Ferrites. A non-reciprocal element should have some discriminatory properties such that the transfer characteristic through the elements along the different directions vary in sign, amplitude, phase, or the polarization or all. Non-reciprocal element. What is that? The material whose the physical properties, probability or the permittivity are not same in all directions can be used in the non-reciprocal element. A Ferrites which the magnetic field has the tensor probability, so it can be used as the non-reciprocal element. This property of the Ferrites is used to the circular as well as the isolated in the microwave frequency. Circular. It has the 3 port and have the following properties. All the 3 ports are the matched, and the second, the when input signal is at the one input, then the output will be port second, not on the third. And similarly, if the input is at the second, output will be on third, and so on. This is just like the cycle. And for the isolator, it is the 2-port non-reciprocal network signal may transferred from the 1 to 2 but not from 2 to 1. It is observed in the opposite sides. Microwave propagation in the Ferrites. The magnetic property of the Ferrites arises mainly from the magnetic dipole moment associated with the electron spin. It is like a gyroscopic top, a classic picture of the magnetization process and the and isotropic properties may be arises. Let G is the angular momentum and capital M is the magnetic moment per unit volume, that is magnetization. The gamma is the gyromagnetic ratio. Then the gamma equal to the M by G, just like the figure, the direction of the M and the G is in opposite to each other. And due to this one, the torque is rises and torque will be due to this one start to rotate. The torque tau exerted on the electron spin is given by the tau equal to M cross B0. B0 is the external field. In place of the B0 we can write mu0 S. So this is the mu0 M cross H. If you write in terms of the G, then it is equal to minus of the gamma G cross B0, because M and J are the anti-parallel to each other. The torque extended on the dipole's moment, this gives the equation of motion. The torque causes the dipole axis to process about an axis parallel to the B0 S on this one, tau equal to dj by dt, and this is the 1 by gamma dm by dt minus gamma j cross B0. Here the j and m both are time dependent, like j equal to j0 e raised to power j I tau omega t and m equal to m0 e raised to power I tau omega t. So dj by dt is equal to I tau omega j. So in place of this equation we can write tau equal to 1 by gamma dm by dt equal to mu0 m cross h, and the j omega m by the gamma mu0 m cross h. So the m equal to mu0 gamma by the j omega multiplied by the m cross h. The magnetic properties of the Ferrites may be the regions as due to the collection of the n effective electrons let per unit volume, and the dipole moment of the each atom is the small m, so the net dipole moment is capital M equal to the m into the n. So in the absence of magnetic field, the dipole moment are displayed oriented in the random directions. The effective result is very small, but the external field is applied, the magnetic dipoles will be aligned along the direction of the field. This gives the total magnetic dipoles per unit volume m equal to capital M, small m. Where B0 is the very large, all the dipoles align, the Ferrites get the saturation m equal to ms. The whole sample acts as a large single magnetic dipoles. The total internal magnetic field will be equal to mu0 m0 plus mh. The torque acting on the electron ms is due to this tau equal to ms cross b, and this is ms cross mu0 h cross 0 plus ms. So ms cross ms equal to 0, so this is equal to mu0 ms cross h0. Thus the equation of the rotation of the magnetization, the field producing the torque equal to mu0 ht the total magnetic field, static as well as the AC. Now the permeability tensor of the magnetized field permits the time varying magnetic field H equal to H0 is to power j omega t iota omega t, and it says the amplitude is small in comparison of the static field H0. This H is associated with the wave propagation in the medium. This gives rise to magnetization M in the materials. So the net magnetic field components are Hx, Hy, Hz plus H0, and the total magnetization is Mx, My, Mz plus M0. Equation of the magnetization can be written tau equal to dm by dt equal to minus gamma m cross b. In place of this one we can also write minus gamma mu0 m cross ht, and in the determinants form we can write in the components iota j omega times x plus j cap iota omega my plus k cap iota omega mz equal to the minus gamma 0 I j k mx my m0 plus mz hx hy h0 plus hz. So this can be done j omega, that is iota omega mx equal to the minus gamma mu0 my h0 plus hz minus hy m0 plus mz. Similarly for the my iota omega my equal to minus gamma mu0 m0 plus mz together with hx minus mx h0 plus hz. Last j omega mz equal to minus gamma mu0 mx hy minus hx my. It is supposed that the mz is very less than the m0 and the hz is less than 0. The above equation reduced to the j omega max equal to the minus gamma mu0 my h0 plus gamma mu0 m0 hy mz. Second, minus iota omega my equal to minus gamma mu0 hx m0 plus gamma mu0 h0 mx, and the last j omega mz equal to 0. So on intermixing the equations we can write first and second. Mx is written like this one, the gamma square mu0 h0 m0 hx divided by the gamma square mu0 square h0 square minus omega square plus iota omega gamma 0 mu0 m0 hy divided by the gamma square mu0 square h0 square minus omega square. So in place of this one we can write omega 0 equal to the mu0 gamma h0 and the omega m equal to gamma m0 m0 mu0. So mx can be written omega 0 omega m hx divided by omega 0 minus omega square, and the second terms is the iota omega m h by omega 0 square minus omega square, and the same for the my minus iota omega m hx omega 0 square minus omega square plus omega 0 omega m hy divided by omega 0 square minus omega square mz equal to 0. So the above three equations provides the relations between the components of the magnetizing and magnetizing field. In general, if there is a scalar, then the chi equal to the m by h susceptibility. So we can write this equation in tensor form mx my mz matrix, and the x chi xx chi hy xy 0 chi yx chi yy plus 0 and 0 and 0 0 0 hx by h0. Here these are the components of the susceptibilities. So the magnetic induction can be written from this one, b equal to mu 0 h total, so mu 0 h plus m. So the bx by bz 1 plus chi xx chi xy 0 chi yx 1 chi yy and 0 over 0 0 1 hx by hy. So the probability tensor is equal to the mu 1 plus x chi xx x chi xy 0 chi yx 1 plus chi yy and 0. This is 0 0 1. And the last, the mu equal to the mu 1 1 mu 1 2 0 mu 2 1 mu 2 2 0 0 0 mu 0. So this is like this one. So use of the omega 0 here, that is gyromagnetic resonance frequency, because at the omega 0 mu equal to mu 0 probability is the no more a tensor but it becomes a scalar, and omega a constant of the metal set, and that depends on the strength of the saturation magnetizing field ms in the parametric domains. So this is all about for today. Thank you.